Sure. So this talk is called Advanced Testing. So I try to keep the examples as simple as possible. So maybe it should be more intermediate testing, but at least I don't feel bad now by showing you a lot of code, stuff like that. So it's the advantage. So as you might know, Go 1.7 was released a few days ago. There's a whole bunch of new features. So one of these, what the talk will be about today, as it was announced, is hierarchical tests and benchmarks. So what exactly does that mean? I'm actually glad it made it to 1.7, otherwise I had a big problem here with this talk today. But so what's new? It's basically two inconspicuous looking functions, or methods rather, on the testing and benchmark types, T and B respectively. So what they do, they allow you to pass a name for the subtest and a function, which is basically of the same signature as if you were declaring a top-level test or benchmark. So you don't really have to read, so you can read the documentation at home, but this is basically what they add. I'm going to talk today about like what does this allow you to do, right? Because it's a little bit hidden. But let me first talk a little bit about the idiomatic way in Go of writing tests, which is called like table-driven tests, if you will. So basically what this is, you have a top-level test function. So what you're trying to do here is to reuse the code, the common code for every test case. So you basically define some structs of some sort, or it could be another type, where you have your test data, and then you iterate over it, and you call this piece of code for every element. Right? This is a very common way of doing tests in Go. It's very Go-y as well. It's very explicit, like linear. You can go straight through it. So this is very nice. So one of the problems people had is that they also wanted to do this for benchmarks, right? In benchmarks, however, this is not possible because basically, if you do the same thing in a top-level benchmark function, you will be measuring the performance of every single entry and not every individual entry. So this is the first example where the run method comes in handy. So let me show you how it was done pre 1.7. So if you want to do at least the same approach of sharing code, you would define a top-level entry for every benchmark you want to run. Then you have a function, and each top-level entry calls with different parameters, right? What you would normally put in a table, you would have to, like now, pass to this function. So using table-driven benchmarks, something looks like this. So you don't have to read all the code. It's more like the general structure, right? So what you would do here, you would call for every entry in the table. You would call run, b.run. So every function passed run is a separate benchmark. The top-level benchmark itself now just becomes a placeholder for the sub-benchmarks. So itself, it's not measured. It's only called one iteration instead of any iterations. And so this is how you do table-driven benchmarks, right? It's quite straightforward. It's the same pattern as with table-driven tests. And it's quite handy. So I've actually rewritten most of the benchmarks in core to use this. So as of 1.7, they're all rewritten and they look different now. And it's so one of the things to note, it doesn't actually make the number of lines shorter or anything, but it's a lot less typing, right? There's a lot less duplication, and it's generally cleaner. It's easier to add a test. It's a little bit more structured. And what you can also do with this, it's very easy to take a cross product of a few smaller little tables, and when you do that, it really starts reducing code. Another thing to note, if I go back to the previous example, you see this little reset timer. Like in this case, it's kind of redundant to do that, but suppose you have a lot of setup to do. In a normal benchmark, you would need to reset the timer, right? So now in this example, I'm actually sharing this setup amongst the different benchmarks. So there's also no need to reset the timer, because the timer starts afresh for each call of run, right? So also there, it simplifies your code a little bit. So I'll talk more about setup and teardown later. So it's clear that this is a big win, potentially, for benchmarks, but what does it bring for tests, actually? So let's go back to table-driven tests like pre 1.7. So here what I see is if I have an error message in my test, it's important that I identify the table entry for which there was a failure, right? Because if I just show the error, I just say got and want. I don't know to which table entry it applies, right? So that's cumbersome. Or not cumbersome, it's, well, it's cumbersome finding out which test you actually had. So now, okay, sorry about that. So this is the output you would see, right? In the output, you have the to upper, in this case, with the original input, and then what you got and what you wanted, right? This is an idiomatic way of writing error messages. So how does it look like with subtests? So with subtests, we're already passing a string that identifies the subtest in run. So really, there's no need anymore in your error messages to identify the subtest, right? So what I could do, I could simply write got and want, and that's enough, right? If you look at the output, you see the output is now hierarchical, right? Like you have a test upper, you have the specific case, which is identified in the name, and then I can just say got this, want that, right? It's, and I mean, here the benefit is less, but if you have a larger test, it can be quite a substantial saving. So another subtlety that changes, so you have this error and like fatal methods on testing. Error is like, okay, you report the error, you continue on. Fatal is like, okay, you know, there's really no point of me for continuing now, so I'm going to build a test. So an example of that is with this little table-driven test, right? So I'm doing some tests using time, and I need to load the time zone for that, but if I cannot load the time zone, if that fails, there's no point in doing the test, right? So I would like to use fatal. So in this case, all the tests are errors, so what happens if I run this? I get only one error reported. Why? Because fatal bails out, and also all the next test entries will not be run from the table, right? So this prevents a lot of people from using fatal, even though they use it, want to use it, or they use it by accident. They get underreported on errors. So since a subtest is just a regular test, if you use fatal here, so this is the same test, now with using subtests, the output looks as follows, right? So again, here's a better example of also the shorter error messages. The error messages that you see here, you know, like there's multiple error messages, and I don't need to repeat identifying the subtest within the error messages. So that's quite handy. And also, if you call a fatal, it will stop that subtest, but will continue on the next. So these are some of the smaller things, right? So my favorite feature, this is actually why I set out to do this in the first place and took this you know, job on, is like a command line selection. So one thing that really bothers me is if I have a table-driven test and I have like one failure, I want to be able to isolate the test and not run everything. So what you had to do before, you had to like find the index of it or the name or some way to identify it, add code in your code, right, to sort of single that one out and then run it again. It's just annoying. So I want to be able to just select the test name or whatever fails, like put it to the run method and then run that test by itself. So this is a little bit tricky how this works, but I'll try to explain it. So selecting subtests, and the same thing applies to benchmarks in this case, by the way. So here I'm repeating some snippets of this table-driven test before. So you see the 3 test cases in this case. I added one. And then the start of the table-driven test. And the important thing to note here is that to run, I'm passing a string, which is you know, the input time and the time zone, so identifying the individual entry, right? So, and the names of the tests that will be used, you can see in the table, right? So basically, the way the test names are composed is you take the top-level tests, and then you append a slash for the subtest, and if there's more subtests, it just continues on, you know, so it becomes a slash-separated list of subtest names. So how do I identify these on the command line? So let's say I want to run all the tests that have the, you know, a time zone that's in Europe. So in this case, I'm just saying like, you know, reset time and then in Europe, right? This was the original like sprintf that you saw. And then what it is, so the argument that's passed to run, it used to be a regular expression. Now it's a slash-separated list of regular expressions. So basically the way it works is like it first splits it up in slashes, if the slash is not part of a regular expression somehow. And then it will use each regular expression to identify the corresponding parts in the name. All right, so I'll get back to that later, what that means. So in this case, you run in Europe. So what you see in the test names, it's actually escaped. So spaces are replaced by underscores. The same thing happens if you pass something to run. Spaces are replaced by underscores. The reason for this is to not break compatibility with tools like bench stats. And then there's some other escaping to not mess up your command line interface and all that stuff. But it's pretty simple escaping in general. So all it does is apply all these regular expressions in sequence, right? And as you see right here, it only gets the first error, and only the first error is printed. So another example, let's say I want to run all the times afternoon. So I added a -v, so you can see it's actually skipping the third one. So you can see after the slash, it's just a regular expression, and it matches. So I could have also, and by the way, in the previous example, I could have just said in Europe with underscore, right? Of course, that's fine as well. So the final example, this is a little bit tricky. So here you see, so you remember we only had one level of subtests, right? But the second or one of the arguments in the creating the name is a time zone, which has a slash in it. So even though there's only one level of subtests, the name have 2 slashes in them. So when you select something on the command line, the slash that's part of the name counts as a part. There's a long discussion about why this is, but it basically has several advantages. So first of all, to the user of like whatever framework that does the test, they don't know if the slash is going to be part of a subtest or not. You don't necessarily want to know the code if you want to run tests. The other thing is it allows you to do refactoring, right? Like you can say, okay, I'll have these multiple levels of subtests, or no, I want to collapse the tables. And you can keep the name the same while changing your code. Also, it resulted in much simpler code in a lot of ways. And if you don't want to have a slash in your name, or if that bothers you, then just escape it somehow, right? So you have the control over the name, so you can do that. Replace it with a backslash or whatever. So in order to match New York, let's say all the New Yorks in any continent, a little bit strange, but let's say you want to do that, then you can pass this, or you could do York, I guess that would work. So you can put that name here, but you would have to specify 2 slashes in this case. So knowing that now, we probably would have done the name differently. We probably would have said, like, join all the arguments that are the input with a slash, and then the test names would have looked like this, right? It's more natural now to pick, using this syntax to pick the individual tests. And in general, if you don't have any funky characters in your name, you can just select a test on the command line that failed, paste it into run, and it will select it, right? So another thing about naming, so the test names are made unique by the framework. So if you happen to have duplicate names, for example, because of the escaping or because you just wasn't paying attention, it will add like a sequence number. So it would look something like this. This would be the output for this. You have 2 A's, 2 B's. They will be extended with a sequence number to make them unique. So you can use this trick to, if you're lazy, you don't have too many tests, like dozen or less, or maybe 2 dozen. Gets annoying after that to identify it. But you can just pass an empty string as the name, and it will just do, give you this number, sequence number. So deliberately it has 2 digits, because if you get past 12 or 15, you really don't want to be doing this. But, it can be handy. So now to a next often requested feature. This is setup and teardown. So some people have asked for like fixtures in the testing framework. Now test fixtures is really something that does not fit within the philosophy of the testing framework. So because basically for you that are familiar with any of the XUnit frameworks, you would have a class where you have like a common setup, common teardown, per test setup, per test teardown, like a bunch of test functions, what have you, other things, and then the framework makes sure these get called in the appropriate order. So having table-driven tests, it's actually quite easy to already do this, right? Like you don't have to repeat the setup and teardown. I mean, you just put it in the loop once, right? It's very clear it's happening there. It's very explicit. In Go, we like explicit, right? We don't like this callbacky thing. So the table-driven tests are actually a very natural place to do this already. However, there are some things you cannot do that way. And the run methods can help here. So if you look at this code, like the one thing that's really cumbersome to do with pre 1.7, let's say, is to have common setup and teardown code for a bunch of top-level tests. I mean, one thing you could do is maybe, like override the main method, which you can do, and then, hack around this. Or you could have, but it's cumbersome and ugly and not very clear. Or what you could do is you could have a test, like a sequential test after the other tests you have run, and then basically make sure you do cleanup there, right? But what if people select tests, then they will, forget probably to select that test as well on the command line, so your cleanup will not be done, or whatever. It's just, messy. With subtests, it's much easier to do. So what you can do now is, here's an example. So we have a bunch of tests, this time not table-driven, not in a loop, but works just as well. So a bunch of subtests with at the beginning common setup code and at the end common teardown code, right? So even if one of these runs fails, it still works, right? If it fails, the teardown code will still be called because it's a failure of a subtest doesn't fail finishing the execution of the parent, right? So this will guarantee that your teardown code will be called at the end. So even though you could do this pre 1.7, so if you have like so per test setup and teardown, the way to do that is to just do it within the loop, right, if you will. But one thing that you could not do, or well, you could, but it was not very convenient, is to use defer in these cases, because typically within the loop you don't call within a function. So if you do defer, it's only cleaned after all the tests have run. But sort of naturally, you get this now for free because you're already doing it anyway. Since you're calling every subtest within a function, it becomes like straightforward to use defer. So it's a little bit nicer. It's not really a feature of the testing, the run methods itself, but it's a happy side accident. So to get to the little bit more complex and advanced topic. So some people wanted to exert more control over parallelism in tests. So as you might know, there's this little obscure method called parallel, which if you call that within your test, its execution will be postponed until all the sequential tests are done, and then it will run all the parallel tests with a certain amount of parallelism, can be handy. So in order to understand how to use parallelism within the new testing framework, how you can control it, you have to understand the semantics. So basically, each test is associated with a test function. So if we think about run, right, like you have the run method, there's a name and there's a test function. So if you call tParallel within that test function, it actually will be run in parallel, right? So it will, if the calling test is sequential, or actually the way it's implemented now always, it will wait until the calling function completes, and then the parallel test will be run, right? And a parallel test will never run concurrently with a sequential test. So another piece, and this is sort of new in 1.7 semantically, it was implied in the old one, but not really, is that if a test calls a subtest, right, that test will not complete until all its subtests are done. So the way you could see this as a run, right, like you have the run method, you call run, it will call its test function, right, internally the test function will be called. That might schedule a bunch of parallel tests. Then as soon as this test function returns, but before run itself returns, that's when all the parallel tests will be run, right? So to give you an idea, like the way it's implemented right now, like all the top-level tests are just subtests of a hidden internal main test, right? So even the top-level tests are called by run. It actually calls run, then runs the function, and then before that internal main returns, all the parallel tests are run. So this allows you to group parallel tests essentially. So let's say I have a bunch of parallel tests that I want to run together, but not together with other parallel tests. For example, I might want to do that because the resources for both of them are too big, right? So I only want to run one group of parallel tests together, but I don't want them, these duplicate resources to be, allocated at the same time. So this is how I could do it. I could basically group, like loop over like a list of tests I want to be run in parallel together. These get started, and then basically before the test group parallel function here in this example like moves on to the next, let's say before the next sequential test is run, these parallel tests will be run, right? So here I guarantee that all the parallel tests will be run together, but not with any other parallel tests. So there's one big gotcha here. That's this little line. So in order to make sure that all these parallel runs don't just execute the last table entry, right? You have to capture the range variable. I mean, this is a common problem in Go. It's very unfortunate. It doesn't jive well with the Go routine thing, but I mean, here there's, it's not very easy to catch this. Like if your last test passes and some of the other ones don't, you'll actually miss it, right? So don't forget to do this. If GoVet doesn't already catch this, then it should soon, anyway. So another thing that's a little bit more complicated is setup and teardown for parallel tests. So as you remember, with the other teardown example that I showed before, I was relying on the fact that if you have a bunch of tests like running, they're sequential, they finish, and then I do my teardown. But basically, parallel tests are run only after your test function returns, right? So that basically, I cannot just put teardown code after running a bunch of parallel codes because that teardown code might be called before the parallel tests finish. And this is even true if I use defer, right? So you cannot do that. So the way to solve this is to use the same trick as I showed in the previous slide, but one level down. So what I'm doing here is I'm introducing another layer of subtests, if you will, where the only purpose is to synchronize my other parallel tests. So what I'm doing here is I'm calling trun for the group, then I'm running a bunch of parallel tests, and I know that my outer run will not return until these others have completed, right? So I can wait until these complete, then call and then the teardown code will be executed. In this case, it will be fine to use defer, right? Because same thing. So that's how you control parallelism. So there is one other thing. I set out to do this. So in the text repo, there's a lot of table-driven tests, and this is really one of these cases where if an individual thing fails, I want to be able to single out, debug it, right? So that's why I wrote this in the first place. However, I need to make sure that my package stays compatible with also people wanting to test it in Go 1.6 and 5 at least, right? So even our dashboard, build dashboard, wouldn't even work, right? If I start using these subtest features right now. So that's a little bit awkward. That means I have to wait about a year or so before I can use this. So I didn't want to do that. So I'm using a technique inside this repo, which I also implemented in this subtest package that I have on my private GitHub. So all that this does is to basically emulate the subtests on the older testing framework. I mean, it won't get you a lot of the features. You cannot select things on the command line, obviously. It will actually be even harder to identify an error in the table-driven tests, because if you remove the identification, it's lost, right? So you won't be able to find it. Fatal won't work. I mean, it will work, but it will bail out early. So all these things. So it won't be pretty, but at least you catch errors, and it will compile, and your test can run, right? So at least that. And then if you really want to like single it out, start running it, you can use 1.7, right? So with using this subtest package, instead of calling trun, you do subtest.run t, and then same arguments, and you basically can keep your compatibility. So this is uses build tags and all that stuff, obviously. So and that's basically it. Yes.